Hello friends, welcome to Artificial Intelligence course. So in this video, we will be going through depth first search technique. So let's start. Depth first search. DFS is an uninformed search algorithm that explores a state space by traversing from the root node to the deepest possible node along each branch before backtracking. It follows a depth first traversal strategy, meaning it prioritizes exploring deeper nodes before moving to siblings or other branches. DFS is implemented by using stack, that is last in first out, or LIFO data structure. Here's how DFS works. First, start at the initial state and mark it as visited. Second, explore one of the neighboring unvisited states. If there are multiple neighbors, choose one arbitrarily. Third, repeat step 2 for the chosen state, recursively exploring its unvisited neighbors. Fourth, if there are no unvisited neighbors, backtrack to the previous state and continue exploring other unvisited neighbors. Step 5. Repeat step 2 to 4 until the goal state is found or there are no more unvisited states. So this is example of DFS. In first step, we will take 1 as a root node and explore to its deepest node. So next 2 and then 4. So the other step, we will backtrack to 1 and then we will go to 3. So in the final step, we have visited all the nodes from 1, that is root node. Depth first search is complete or not complete. DFS is not complete in itself because it can get stuck in an infinite loop if the search space contains cycles. However, if the search space is finite and there is a goal state reachable from the initial state, DFS will eventually find it, that is, it can become complete. Time complexity. The time complexity of DFS depends on the branching factor B and the depth of the shallowest goal node, that is D, in the search space. In the worst case scenario, where DFS traverses the entire depth of the search tree, the time complexity is big O of B raised to D, that is, branching factor raised to depth of the shallowest goal node. However, it's important to note that the actual time complexity of DFS can vary depending on the structure of the search space and in the order which the states are explored. In the best case scenario, where the goal state is found at the shallowest depth, the time complexity can be as low as big O of 1. DFS has an advantage in terms of space complexity since it only needs to store a single path from the root to the current node, making it memory efficient. Overall, DFS is a simple and intuitive search algorithm, but its completeness depends on the nature of the search space. It is suitable for search spaces with limited depth and is often used in applications where memory usage needs to be optimized. So friends, this was all about depth first search. In next video, we will be going through breadth first search and other uninformed search algorithms. Thanks for watching till here and don't forget to subscribe our channel.